Let's take a look at topic 5.6, find an equation of an inverse relation. In this video, we're going to review example 2 and example 4. So first thing we're going to do when we're going to write the equation of an inverse relation, we're going to switch the x and the y variables, and then we're going to solve for y. So let's take a look at A. We have f of x equals x squared. Let's find the inverse relation. So remember that f of x is essentially y. So we have y equals x squared. Now I want to switch my x and my y. So I now have x equals y squared. If I'm going to solve for y, I need to get rid of that square. We undo a square with a square root. And don't forget, when we're doing this and we have an even index, even exponent, you are going to use plus minus. So we are left with plus minus the square root of x equals y. Now, this is not a function. And we're going to take a closer look at that in another video based solely on taking a look at graphs of functions and their inverses. But if you recall in our last section when we looked at it, was actually 5.3, and we took a look at the graph of the square root of x. Remember we had that domain restriction and we kept everything as the principal square root. We restricted that domain to values that would not be negative under the radical. That is y. So here we go. Number 2, try it. F of x equals 2x plus 1. So again, I'm going to write this as y equals 2x plus 1. And now I'm going to switch my variables. This is now x equals 2y plus 1. And now let's solve for y. I'll subtract 1 from both sides. X minus 1 equals 2y. And now I would divide both sides by 2. And don't forget, you're dividing both of these terms by 2. So I'm left with right here, x minus 1 over 2 equals y. Let's rewrite that. I'm going to write that as y equals, remember that 2 belongs to each of these terms. So this can also be written as 1/2 times x minus 1/2. And I think in this form, it might be a little bit more easy to recognize that this is a linear equation. If it is linear, and again, remember, this is in the form y equals mx plus b, we're in slope-intercept form. If you have a linear relationship, this is a function. And now, because it is a function, I can use my inverse notation function. The inverse of x equals 1/2 x minus 1/2. Let's do 2 more. So again, my first step, let's write this f of x as y. We have y equals the square root of x minus 2. And now I'm going to switch my variables. I have x equals the square root of y minus 2. And I want to get rid of that radical, square root. So to get rid of the square root, I'm going to square it. And I'm going to square both sides. So I now have x squared equals y minus 2. I'm going to add 2 to both sides, and I get x squared plus 2 equals y. So now notice this is a quadratic, and quadratics are functions. So again here, I'm going to write this using my inverse notation. So the inverse of f of x equals x squared plus 2. You can only use this notation if it is in fact a function. Let's take a look at B. And looks like I left off a negative. There should be a negative here. So it is the negative cube root of 4x. So again, this is a y equals the negative cube root of 4x. I'm going to switch my variables. I now have x equals negative cube root of 4y. The first thing I want to do, I want to get rid of this negative. Think of this as a -1 here. So you could either divide or multiply both sides by -1. Essentially what that just does is it flips your signs on both sides of the equal sign. So I now have negative x equals the cube root of 4y. And now let's undo that cube root. To undo the cube root, we're going to cube it. Raise it to the third power. That exponent undoes the index. I now have negative x cubed equals 4y. And now let's divide out the 4. And I'm going to have negative x cubed divided by 4 equals y. Now, again, you can think of this as well as a -1/4 x to the third. This is cubic. This is definitely a function. Cubics are functions. So I'm going to use my notation. This is the inverse of f of x equals, and I'm going to go ahead, I'll write this as a -1/4 x cubed.